Greetings to everyone this evening. I am honored to present the impressive profile of our resource person for this session. Mr. Revanur Harikrishna is a seasoned technology professional with an impressive 24 years of career spanning multiple critical domains in the IT and technology landscape. Holding a master's degree in electronics and instrumentation, has developed extensive expertise in embedded systems, delivery leadership, pre-sales, and account management. Throughout his distinguished leader career with renowned organizations like IBM India Limited, HCL Technologies, Tata Advanced Systems, Mistel Solutions Private Limited, and Trident Infosol Private Limited. Hari Krishna has established himself as a strategic leader in hybrid and multi cloud migrations and modernizations of applications and infrastructure across major hyperscalers, including AWS, Azure, and GCP. Currently serving as the director of cloud migrations and modernizations generative AI cloud at Tata Consultancy Services in the UK since 2023 June. He continues to drive innovative technological transformations and leverage cutting edge cloud and AI technologies to deliver complex business solutions. It's clear from Mr. Harikrishna's profile that we are in for a valuable session. Let us welcome them to our midst. Thank you.
Okay, thank you, sir. I was there present in the previous session just half an hour before I joined. It was very enriching and knowledgeable session from the professor. But to be very frank, you people are all who joined. No, I was able to get a little bit of persona of the individuals who joined this session. Most of them are all research scholars, and they are students and as well as PhD pursuing personals and as well as professors as well as lecturers and all. You people are more knowledgeable than me, frankly speaking. Okay. However, having said that, and I would like to have this entire session more interactive. Okay, just don't want to just put some slides and then bore you. And I know it is already 8 o'clock, and most of the people, would like to go have their suppers and then want to take some rest and spend time with family and all. So I will be as much as possible. What I will do is I will divide this entire session 1.5 hours into 3 different parts. Okay. The first half an hour, I would like to present the session which is related to the theme of this entire gamut for the last 1 week, what we are presenting and every individual is presenting. The next half an hour, I also would like to talk about the AI and the trends, how the market looks like, and what is happening around the world, how the companies are perceiving the technology AML. The last half an hour, and we will have more interactive sessions. And I would like to touch upon some career guidance and what exactly you need to focus once you come out of your colleges or from out of your research degrees and all, know how you would like to perceive your careers and all. And then thereby we can also have the Q&A sessions if time permits. And if I could able to answer, I will answer it. If I could not able to answer those questions, I will definitely try to answer that by doing my own research, or I will ask the people who knows those questions. Okay. With that, let me jump into the session. Let me share the screen. Okay. Today's topic, I think for the last 5 days in this week, it was moment of marathon sessions, especially in the technology area. And especially on the semiconductor side, that's the theme. And today's session, we are going to talk about the advanced semiconductor packaging technology. Of course, it is powered by artificial intelligence, AI integrated next generation technology. So this is me, Revanur Harikrishna. You can call me Hari. Let's move to the agenda for this session. What I would like to take you through all this session for next coming 1 hour is that I'll just would like to touch upon the introduction, which sir has already done it, but I would like to also touch upon how I have evolved and how I started my career, and probably that would help some of the individuals to see that how you need to grow in industry and how we need to pursue our careers. Then we will start with the advanced semiconductor packaging and the concepts. Then we will also touch upon the technologies, tools, and innovations happening in the semiconductor packaging stream and area, and key advanced packaging technologies, the materials that are used, tools and techniques. Then we will also see industry applications and trends. Then finally, we will also conclude how exactly the future outlook look for this particular industry. Okay. And please stop me in case if anybody have questions. And as a as my nature as an industry person, it is always overall talking more and more, because that's what we do in our day-to-day activities. We talk to the clients, we talk to the team members, we talk to our customers, we talk to our peers, we talk to the other companies, vendors, and all. So if I'm talking too much, or I'm going off the track, or would like to have some questions, you can always stop me. You can always ask me questions. I have no problem. We will get into that and we'll solve those questions, and then we'll move further. With that, this is the overall gamut of my entire span with 25 years of experience in industry. So I started my career after completing, and just to let you know all, I'm from Anantapur. I born and brought up there from KG to PG. It's from Anantapur, Old Town, Sainagar. Those are the places that I grew up. And I came to know about this session. I was asked by one of my, peer, Anjulata, Dr. Anjulata. She has been my classmate during my post-graduation. We did Masters in Electronics and Instrumentation in Sri Krishna Devara University Science and Instrumentation Center. So that time she happened to be my classmate, and later on she pursued her PhD, and then that's how we still in connected. We have our own group, WhatsApp group, and she keep requesting people to help the students and give some kind of sessions or any materials or any guidance or coaching in that group. And most of my classmates are spread across the world. People are in Germany, Singapore, and all. They are all working in different organizations. To name few, Tata Alexi, and some people are working in Allen Broadley, and Tata Technologies, and HP, Accenture, etc. So in that group, she actually requested me, saying that there is a session that needs to be actually presented. And then she happened to be requesting me 3 months back, and there was a face-to-face in-person session also happened. I couldn't able to travel that time because I was in business trip. And I actually given some reference, and one of my junior came and presented. Then I promised her definitely in the month of December, whatever it may so, I will definitely take a session, and I will just share my knowledge and my share my experience, whatever I gathered over a period of time, to all the students and then research scholars. So that is the crux of the story why I'm here today. And I spent most of the time in Bangalore. And I started my career in embedded systems, working very closely with defense and aerospace. And name the technology in the defense I have worked. The first 13 years of my career is completely into DRDO, DLRL, radar processing systems, missile checkout systems. And I'm so proud one of the program that I executed. I have traveled to Israel Aircraft Industries, but a light combat aircraft vehicle, to do the ATP, acceptance test procedure, for the front-end telemetry station. That actually now, all Tejas LCA, correct? So that was done by ADA, Aeronautical Defense Establishment Laboratories, along with the few scientists. I was fortunate enough to travel along with them for almost 25 days and perform the ATP for the front-end telemetry station. And thereby, once my movement to the data center technologies, infrastructure, and the cloud happened, After I was working with HCL Technologies in Boeing C-130 AMP, which is avionics modernization program. C-130 is a military aircraft which is a carrier. I was also certified DO 178 level B associate, and there I got an opportunity to work in system technology group of IBM to test the kernel AX. AX is a proprietary operating system from IBM, and this kernel for 6.1 version, I've been deputed to US in Austin System Technology Group to actually subject this entire kernel to test panic, that is system stress and IO functionality team. That means we stress the kernel and we will see how the operating system is getting panic, how it will crash, and what are the symptoms of this kernel, what are the timers, the other parameters, and the other attributes inside the operating system, how exactly this is creating the stress in the overall operating system. That was the objective. During that time, I have got an opportunity to work multiple storage technologies, starting from NAS and SAN, storage area networks, and network attached storage, and the file systems, filers, and all. That so happened that my entry into data center technologies after spending 13 years in embedded systems. Then from there, I joined IBM around 2009 as a SME, subject matter expert for the IBM storage area networks, IBM SAN. I'm actually I joined as an architect. I was working on SVC. It is a SAN volume controller. It's an enterprise class storage from IBM. That's where we started working towards that, and then I got an opportunity to elevate it to management side, and I became a delivery manager sometime in 2010 and 11 that time. After that, IBM actually acquired the soft layer, which is nothing but now it is called IBM Cloud, which is again more into the cloud migrations and cloud modernization and all. In 2014, we started with a very few people called Cloud Migration Factory within the IBM, and I happened to be one of the incubate team and one of the member over there. Then we started slowly moving the workloads from the customers that are hosted in the existing data centers of IBM and to the cloud, IBM Cloud. Later on in 2018, we realized not just only the IBM Cloud, we focused on AWS, Azure, GCP, and all, Google Cloud. We started partnering with them. We started developing the offerings like where migration as a service, discovery as a service, and then we also started working on the execution part, all different offerings. And then we also tapped the business of modernization, application modernization, not just only focusing on infrastructure side. So we started migrating that. Sometime in 2021, and I have got an opportunity to join TCS as a director, head of technology and transformation. And that's where I grabbed the opportunity. I joined TCS. Since then, I am with TCS for the last 3 years. Currently, I'm heading the UK 2.3 cluster as a cluster head for the BFSI segment. And I'm managing the cloud transformation programs. And it's a very huge multi-million dollar transformation programs. So I'm actually, if you look at on the screen, I'm so proud to tell about myself that I'm IBM certified Blue Core coach. So I'm also a certified speaker from IBM, and I'm IBM certified mentor, and I'm a practitioner, certified practitioner. That's about a little brief about myself, and yeah, that's it. And apart from that, what I do, correct, I will ensure that when you complete this entire session, correct, you will take at least three of the things that you will carry throughout your life. I'll ensure that. Okay. One is that how exactly you need to show your attentiveness when you start your career. How exactly you need to be the inquisitiveness that need to get developed inside you. Okay. And how exactly you need to encapsulate and then utilize the opportunities that is surrounding that comes, correct, when the opportunity knocks, how exactly you need to take, correct. I'll tell you, I was a topper in the university. and I was actually, I carry a lot of self-respect, and it so happened that when I was doing my project work, I have done my project work in electronics. I designed a target board microcontroller for emulator, in circuit emulator. I will start talking about all these technologies as we move further in the slides, but I just wanted to take some 10 minutes to talk about what exactly I did and how exactly it benefited. Correct? What happened during my first company? While I was in the project work itself, I got an opportunity. They gave me an offer letter. I got the offer letter, and after 3 months of working, I came back and I have did my final semester project presentation. During that time, I was so proud. There was a little, what to say, like I would say, like, I mean, not ego or something like that. I feel like, I mean, I have achieved something, because 2001, that is a time where exactly the recession started, and I was one of those very few people who got placement. Rest of my peers little struggled. Later on, they also got well settled, but I was carrying a little pride. But this pride did not last long. Correct? When I just entered my first day in Hyderabad, my manager, who was happened to be my mentor throughout my career, he just asked, "What are you?" I so and so. I'm a gold medalist. I'm that, this, and all. So your electronics? I said yes. What he did, during lunchtime, he went and brought one transistor. That small radios used to be there, no, those days. He gave it to me. This is not working. You're electronics guy. You did masters in electronics. You have gold medalist. You're so proud about what you have learned. Just fix this thing. I was like shocked. Why he is doing like that? What is the reason? And I say, like, no, why should I work? I should work in technology. I should work in VLSI. I should work in what to say, like an FPGA designing. I should work in PCB designing. I should work that, this, and all. But I thought, like, why he is asking? So he was observing me. And there were product engineers, and then there were application engineers sitting besides me in the office. I was just young, 20, 21 years engineer. What I did, I took the transistor. There was only one computer was there. I simply went there. I googled it. I have started downloading all the PDF formats of that PCBs, printed circuit boards, and all. There was obviously the multimeters, functionalizers, everything. It was a basic electronics company. Electronic setup was there. I started taking notes of each voltage and all, everything. I started preparing, but I was not even 5% through it. One day happened, 2 days happened, 3 days happened. So he did not came and speak to me, did not disturb me. After 3 days, I went to him. And then I asked, "Sir, I have prepared this inventory. These are the components which I see that I feel it is failing. It failed. I need more components. Please, these components can be given to me. I will do the further testing." Then he looked at me and he said, "Sit." I sat. Then he said, "Okay, leave this thing." I left it. Then he immediately called. There was another senior product engineer is there. He was there. He called, said, "From tomorrow onwards, take Hari Krishna to customer place, DRDO." I was so shocked. He was observing me whether I will accept the task given to me, whether I will bend, I will let go of my pride as a fresher, whether I will work what is been assigned to me. Does I have interest? Does I carry the spirit of learning? All these symptoms, all these parameters, all these attributes, characteristics for any fresher or an engineer to start their career, he was observing me. That was my first lesson. I will never forget throughout my life. Okay. The next day, he took me directly to the RCA, Research Center of Imarat, and trust me, the kind of exposure I got during starting off my career, never I have imagined in anybody would have got. I started working on command control centers, big defense projects. I worked on umpty number of technologies. I got access to tools, technologies, emulators, simulators, everything. 13 years I thoroughly enjoyed. Okay. That's what I'm saying, that if you want to start career, this is for those who are young, dynamic, and looking forward to get into their careers, looking forward to start their careers, looking forward to see how exactly they need to shape their careers. This is one of the lesson I'm saying. Grab the opportunity, leave all your pride, get on the ground, fold your sleeves, start working. Whatsoever matter doesn't matter, correct? You need to start working. You need to take those things. You need to start your focusing into your journey. That's how I started. I think enough of my gnan. So let us get into the real topic now. Okay, what is semiconductor packaging? Why do you require packaging? First of all, I wanted this session to be more interactive. I think somebody can unmute and then talk to me if possible. I don't mind, because I feel very bored if I start to only presenting the slides and then nobody listens to it. Doesn't make any sense, like as if I'm talking to my a wall, because I even don't see when I'm in a presentation mode, correct? I don't see anybody's faces also. Can anybody tell why do you require packaging? Don't be shy. That's what I just told for the last 10 minutes. No need to be shy. Why do you require packaging? It's all there on the slide. Somebody even can read it, is more than sufficient. Okay. I think people are very shy or they don't want to talk. It's fine, no problem. See, why do you require a packaging for semiconductor? It is because to protect. Correct? You need to protect from environmental hazards, from physical damage, from power surge, from interferences, for anything. Okay, electrical interference, magnetic interference, power interference, or it can be a physical interference, anything, correct? To protect that, you require a packaging. So, the process of protecting any semiconductor, either it can be a chip or a component, okay, to protect the core electronic logic inside that component or inside that IC is nothing but like packaging. There are the key functions. One is the protection for electrical connectivity, for thermal connectivity, for thermal management, and for mechanical support, and for miniaturization. That means, like, I mean, as you know that now, no, earlier I was seeing, attending one of the session previously, and he was telling, like, I mean, multiple layers, and I become, nowadays the components become so small, it will go and sit easily on your mobile phones, palm tops, iPads, laptops, miniature. For this, you require a proper protection. Okay, and there are different kinds of packaging out there. You have a wire bonding, you have a flip flop, and WLP wafer level packaging, and then 3D packaging and system in SIP packaging. We will start seeing these things in the coming slides. And how exactly these functionalities are helpful. And I must say, like, I mean, for the last, I think I have seen the themes of the sessions. You would have already gone through many sessions on the semiconductor, what is there inside the semiconductor, what is there outside the semiconductor, what are the materials used, etc., and all. Okay, I don't want to get in there. I wanted to keep these sessions very simple, straightforward, to ensure that everybody understands. Okay, I don't want to talk very hi-fi stuff. Let's stick to what exactly is that, how exactly you will understand what you will carry off this session after 1 hour session, and how you memorize it and how you will register it. Okay, I will take you through this slide in that manner, in that fashion, correct? So we have seen that why it is required. We know what are the key functions. We know what kind of types of, there might be still more. I just actually articulated and just put it to only the packaging types that are highly used in semiconductor industry. Okay, packaging is a very critical step for the electronic devices to protect, to ensure the functionality and the longevity. So these packaging technologies of those chips are very helpful and will be used in many EV, IoT, or it can be 5G technology on the boards, on the motherboards, or on the cards, on the data acquisition cards, on the ADC cards, and the processing systems, anywhere across. That's why you require this packaging. Now, Earlier session, the professor spoke about the number of tools that have been used. Okay. Here also I would like to talk about some of the industry performance tools used for packaging. Okay. And what are the benefits of those tools? How exactly utilized? Correct. I personally have used these tools during my starting of career. Cadence is one of the most popular tool that is being used. And then CMOSL, the multiphysics, it offers the modeling, correct, thermal, mechanical, electrical behaviors of the package. Then ANSYS IC pack, this is for the thermal and the heat sinks, and as well as the temperature simulations, and all these tools are used, popular tools. Apart from that, there is a one more popular tool, it is called Tanner. At least I don't know whether it exists now and all. I used that tool especially to do the some thermal analysis. That means you have a multi-layer board when components are placed, and this tool will tell that what is the temperature around that components when it is subjected with the defined amount of current and the voltage that pass through. Okay, that analysis, that mechanical stress analysis it does, and it will give a very good simulation in the real time. What is your the thermal characteristics of the components and the PCB layer of the circuit boards. With that, you can plan your what you say like your heat sinks. You can plan your the cooling of there are some pipes where you have a liquid, a certain liquid that flows through the pipes to ensure it will absorb all the dissipation of heat and all the cooling mechanism, everything you can plan. There is another tool, it is called Intusoft, and this tool also I have used it. This is for the signal integrity and power integrity analysis. Just before the session, he told what is signal integrity and power integrity, correct? Signal integrity is ensuring that the signals are passed through without having any interferences. That is called signal integrity. That means when you have a multi-layer board, when you place your components, your packages of the components and all everything, you will seal it. When it undergoes the voltage and the current, correct, it generates a kind of a signal noise, correct? How exactly this noise plays? Actually, noise plays a wider important role in a signal communication, in mobile telemetries and in telemetries, and as well as in a telecommunications. These noise signals are very dangerous. And there was a story I heard, like when I have attended some EMI-MC course, actually, one of the scientists in DRDO told us the EMI-MC signal, no, just because of that, but that entire, in World War II, the entire ship actually engulfed into fire because of this one small noise signal that generated by EMI-MC. So there are tools available for the electromagnetic interference and electromagnetic compatibility, EMI-MC conductivity. And then you have a 3D modeling. You can also see the three-dimensional modeling, how the mechanical fitment of these components and all everything. There are tools that exist. And this also will help us to understand the packaging of high density pins. And as it goes miniature, as the pins increases, it is important for us to understand how this is going to be placed on the board, circuit board. So for that, all these tools are exist in the market. You can utilize it, but these are all licensed. It's very costly. Okay, but it is important to know that in market, the tools exist that can do the packaging analysis of your semiconductor devices. Okay, and there are actually other key features of analysis of dyeing, caching, leads, seals, heat sinks, etc. So all these things you can analyze it using these tools. Now, this is one of the important thing I wanted to observe very clearly. Okay, if you look at the right side, correct figure, you see there are 3 levels of packaging. Level 1 talks about the component level, that is at the chip level. level 2, you can see it is talking about the card level, correct, here. And level 3 packaging, it talks about the backplane. This is used to call backplane or motherboard, whatever the terminology used for your understanding. In industry, we call it as a backplane. These are that level. At every level, you require a packaging. Okay. So that's what this entire packaging and how exactly these different layers and all it is at a different levels of packaging it is required. It is being depicted over here in the right hand side. Correct. So what are the benefits of these techniques? Correct. Advanced techniques. Why it is required? One is that it increases the connectivity and it increases the connectivity and density and performance, correct, and miniaturization. So you can able to concise a component, and it can go on like there are, I don't know how many of people you know SMDs, surface mount devices, SMDs, correct. So these are all coming very small, the thickness is such a way that your hairline, correct, your hair is that much you have the ICs developed, it can go and fit in a place. That means you think how technology is improved and how the industry is actually advanced, and thereby the tools, techniques, these are also coming and increasing. There is a plasma dicing and die attached automation, high speed placement of dies, complex packaging configurations, all these things. So precise cutting using lasers and all these things are. We will start talking about those things in the upcoming slides, how exactly those are all there. Okay. Now, what are the different advanced materials that are used in packages, semiconductor packaging? The longevity exists. It won't get spoiled in a very less time and highly reliable. So the advanced materials that have been used so far is that epoxy modeling compounds, EMCs they call, and then low-key dielectrics, graphenate. These are called graphene. It's some nanomaterial kind of things, an advanced material, chemical material that is being used. The techniques that they use is that WLP, which is a fan-out wafer level packaging. It provides a high interconnect density and smaller footprints. With your entire the board and the components the footprint is reduced so small it can just go and fit on your small what is like PCB, and it can go and sit on your in your mobile phones, small mobile phones, or anywhere else actually. Okay, and you might have seen that people use the wireless nowadays. AirPods coming, you just keep the pod in your ear. You don't even feel that there is something sitting in your ear, but you could able to hear, take the calls and all. No, these are all actually the advanced techniques that help the semiconductor industry to elevate that level where space is no more constrained now. Space has reduced so drastically that by using all these techniques and packaging methodologies. Okay, then the hybrid bonding. This combines with the wafer to wafer and die to wafer and the integration of the components, SIPs. These are all actually multi-level ICs interconnectivity, the passive components that are placed on your boards, correct? And these are widely used in smartphones, AI processors, automotive electronics, and the 5G devices. Nowadays, you are seeing that 5G has become predominantly vibing throughout the world on 5G. India, we still need to catch up that, but still, these are the places where you use these materials and packaging techniques that will yield you benefits. Now, I would like to touch. I think these are the couple of topics. Normally, during academics, you will not come to know. Okay, you might have not even heard about these topics, and this is what I was telling that you can proudly go after this session and talk about these topics. what exactly VME, what exactly CPCA, what exactly PMC and IP are there. VME are, these are all like for example, in your normally on your laptops or in your desktops, no, this you cannot take it to any of your terrain places. For example, you cannot carry your HP laptop or you cannot carry your normal laptops to lay, or maybe like very in the submarines, correct? You cannot carry those in high terrain conditions. That means where temperatures are very very extreme. Okay, because the normal components and normal PCI bus factors, it will not withstand the temperature and the environmental conditions of that places. So you need to have in a specialized form factors in a semiconductor technology that will help and withstand and able to carry the same amount of work that carries by normal temperature. So that's where this buzzers, which is ANSI Vita, these are standards actually. So existed. One is a versatile modular Eurobus, then compact PCI, then the fourth one is called PCI mezzanine, and the fifth one is the third one is called PCI mezzanine. The other one is called IP, industrial pack modules. What will happen is these are just backplanes like how I shown earlier, and the coming slides I will show how exactly it looks like, where exactly you are going to place it, what exactly it will carry. Just remember this slide: VME, CPCI, PMC, and IP. I really don't want to read something exist on the screen. I hate that. But you can say like, these are all the different form factors, and this will carry the electrical signals. It's like your backplane, and you can do whatever you're normally going to do it on your normal motherboard or your PC. Now, you look at here, if you are able to see, these are the two white strips that you are seeing. All these components, they did the packaging and all, correct? These are the PCA signals. When it will go, and if you see here, these are the slots, correct? This is called wedge locks. This is called wedge lock. This is one of the VME board. This entire board, what you are saying as single board computer, it is called SBC, single board computer. What it does is that this is a VME backplane. The connectors you are seeing here, it will just go and sit here. You just press it and lock it in the chassis. And then these connectors, what you are seeing is called a PMC connectors. This will go and sit on the top of these connectors. And then this is a front panel will be opened. There will be cables attached to that. That is called mil standard cables. This will exactly replicate like your computer. This probably you wouldn't have seen this thing ever. You will not even know. This only happens in defense and aerospace, where this will be subjected under tremendous environmental conditions. Since the wafer type components and then the leads, whatever you are seeing here now, this will carry the signals and it will have the holding capacity. There will be tests that will be done, shock test, temperature test, different standards are there, mil standards, and this will be subjected to that kind of testing methodologies. Okay, now, so these are all the data acquisition cards. It can be this is the chassis what I was talking about. This will come and sit on here, the slots here, you see these two, this will go and sit over here, this entire thing will go and sit here here, and when you close, the enclosure will become like this. These are all the CPCI and VME kind of boards, and this is another data acquisition or the data ADC cards, data acquisition cards, everything will be there. And RS232, RS422, name it, whatever it is there, this can become like this. These are the PCI signals, general industry standard PCI interconnect, correct? PC interconnect signals, PCI signals that will be carried out, and it will be sitting in this chassis, the backplane, and you can also see front side the projecting the ports, correct? These are the RS232, RS422. These are the fiber optical cables. This is called SFPs, small form factor, SFP. So this will carry the optical signals from this board and then do the processing, give back, and there are sensors, signal conditioners, devices, everything will be embedded in the boards, and that will go and sit, and there is a backside, and even the connectors. Normally, when you connect your mobile charger, when you connect your normal 3-pin connectors and all, no, these are all different packaging. Okay, since we are touching the semiconductor, and I would like to elevate this session from semiconductor to a board level, from board level to an integrated chassis level, or in industry, how exactly it will happen. Okay, I just wanted to touch upon that, and I want to give this what is a knowledge session which I have acquired over a period of time, so that you also know these things, and you are not going to be any geek tomorrow when you go and attend the interviews or wherever it is there. So you also see here there is an Ethernet connectors here. You can connect the Ethernet cables. Okay, USB connectors are there here. You can connect the USB cables here. USB connectors are there, but this will go and sit here in the chassis. Okay, this will carry the entire electrical signals across the backplane, and there is a cooling mechanism down. There are fans that exhaust, and it will see. Always remember, in any electronic system, in any electronic carrier, the airflow will happen in a jet format. Okay, so whereas the heat will travel inverted jet and the cold will travel in the reverse jet. That means your heat will come down, but whereas your cooling system will take it to up, and thereby it will nullify, exit the entire heat dissipation out through this cooling mechanism. There are fans underneath. Okay, that's how it will work. And normally you don't worry about the what is 6U, 3U and all. U is a industrial terminology that is being used. 1U is equal to 44.44 mm. That means this is 6U. So that means this go and sit here in a 6U carriage. So if it is a 3U, there is a very small, like this only, there is only one chassis will be there, and then it will go and sit over there. That's how it will work. Okay, now this is very important. As I told earlier, you look at here these components, correct? These are all different packaging. You might see this looks like some your tap nut or nalika tap, this what is it, like, I mean, interlocking system. No, it is not. These are all the packaging technologies and the connectors that is being used. Your power signals will go through this. Your like, let's say, like 230 volts, whatever it is, an AC, DC, everything will go through this. When you log this is correct, this will go and get this. These are the holes you are seeing, correct? This will go and sit over there inside. It will become, and it will be locked. These are all called the locking mechanism. It is so rugged. If you jump on this and you put some 30-40 kgs, nothing will happen to this material. That's where your packaging is so hard, and your mechanically it is interlocking system is very good. And similarly, this you might have seen in your PCs. It is called FRC cables, flat ribbon cables that will carry your. I just for the distinction sake, I have put it here. The same signals what it goes through your FRC cable. In the case of mill standards, it will go through these components. Okay. Similarly, this will carry. These are all the form factors SFPs I told. Internally, it looks like that, like this. Okay. These are all the PCB connectors. You see, so thick how it will carry those signals, everything. And there is a marking inside this 1, 2, 3, 4, 5, 6, something like that. This comes very standard actually. And there is a crimping tool that will be available. You just need to insert that pin. All these wires will be taken out. There will be a cabling mechanism, and that cable will go and get connected to, this is a female connector and this is a male connector. So that's how it will get connected. That is how the entire, the packaging of the components, packaging of connectors, packaging of electronic components exist. Okay. Now, so far we have seen different kinds of packaging techniques, packaging methodologies, materials used, and in a normal scenario how it will be used, and in mill grades how it will be used, All these things you have seen. Now let's come to, okay, if you just package, does not make any sense. You need to test, correct? Whether your packaging is correct or not. You need to inspect. For everything, what you do is like you need a verification and validation, and you need to know whatever you are doing is correct or not. Like how you write the exams, your professors will correct. Even this, now when you design certain things, you need to understand certain standards. It is being followed. Is this everything is correct or not? Is this properly done or not? Is there any leakage? Is there electrical leakage? Is there any thermal leakage? Is there anything problem with that? So there are different kinds of inspection techniques exist. There are many of the non-destructive testings. This is called NDT. It is a very industry-defined technique. It's a very years-old technique. It is still being functional. It is still being used in the industries. The only thing that happened is that the inspection techniques start actually evolving. Earlier, there used to be X-ray inspection. Okay, they take the X-rays and they detect the joints, interconnections, the entire packaging of the components, whether it is getting on the PCB when you place, whether it is getting connected or not. That X-rays used to be taken. Then there is a optical inspection, automated optical inspection. So there will be a small cameras that will be driven into the places and see that whether the signals are passing through or not, whether the components are really sitting on the board or not. All these things will be seen. And then thermal imaging techniques. And then there are like lasers also used. I didn't have space to put those things. There is a laser techniques also available, and there are some ultrasonics that is also available, and they do all this kind of techniques for the inspection. Apart from that, nowadays the detection, correct? Earlier session they were talking about the AI ML, writing a deep learning algorithm, talking about the defects, supervised learning, unsupervised learning, etc. and all. Similar way here also it start evolving, correct? Now the entire world is revolving around the artificial intelligence, machine learning and all. Even in semiconductor packaging today, AI has been used. AI has been used in such a way that when we train the system by using this method, but this amount of density of multiple layers of the board of these many components with these sizes, what would be my failure rate? That is the level of AI techniques being used today. Something you may call it as a predictive analytics. Something you can call it as failure model analysis, FMEA. There are different techniques are there even in AI also, correct? That's what about the semiconductor inspection and techniques. I think I've been talking for the last 1 hour. I would like to stop here and take some questions in case if anybody have. Otherwise, I have one more slide. Then we will start covering the third part of the presentation, which is going to be your career guidance, and then what are the trends exist in market, which stream you need to choose, how exactly you need to go, etc. So is that okay? We can take the questions from here, or do you want me to move further? Now, this is again correct. I'm coming from industry background. Ultimately, what requires money? Money matters. Business matters. Correct. So for all the organizations, you require money to give salaries. You require money to feed them. So profit, loss, all these things matters. Correct. Now look at the NGSP, GSVMPO. Correct. A global semiconductor packaging materials outlook. What this business is bringing, you have untapped business of $26 billion, which is approaching $30 billion by 2027. Okay, that is a market share. if somebody wants to make their careers into this industry just by inspection of techniques or materials or packaging, semiconductor packaging, you will have a lot of bright future, because there is untapped business of $30 billion exist. Okay. The market share is split across the substances used for packaging. Almost 60% of the share is taken by laminate substances. Then the major share is lead frames. Then you have seen that, no, like, WLP, dielectrics, chemicals, die attached, all these things. Okay. And I just left it here. You can go on, click this link and understand more about this. The industry is increasing year by year 5%. Every year it is increasing 5%. That means whatever the mobile phones we are using, whatever the wearable technologies that you are using, your smartwatches, your iPods, iPads, iPhones, your mobile phones, till this exists, this industry is evergreen. There is no death to this industry. It's an evergreen industry. You can venture it, you can do research, you can get jobs in this. There is a lot of growth in this industry because of this business, $30 billion business. Now, let me conclude my presentation with this last slide. And of course, we will talk about next half an hour more about the career guidance, trends, Q&A, everything we will talk about that. Okay. So even in semiconductor packaging, AI and RPA is influencing a lot. Okay. When I say RPA, it is called robot processing automation, robot process automations. Robots have come into place. There is an automation. You'll just give the command. It will do all your packaging. It will does everything for you. The machines have come into picture. Okay. And the robotics are so precisely, the precision is so good. Their efficiency is very, very, very good actually in semiconductor packaging. So there are places, pick and place machines available. And then there are actually the laser is being very widely used in the semiconductor packaging for the signatures. If you take any of your components where you can see like Intel or your AMD and all, these are all done by using a laser. It's called laser signatures. Okay. And these are very accurate in cutting the chips. The extra material that is being used, that will get cut and very precisely it will be done. Apart from that, I wanted to touch the topic on digital twins. Does anyone know what is digital twin? Don't know? Okay. Digital twin is the latest digital transformation technology that has been there across industries, where AR, VR, correct, augmented reality and virtual reality predominantly became the dominating factors. That means, looking at here, you can see the Taj Mahal. Looking at here, you can feel the Western Ghats in Mangaluru, Udupi and all. So even in semiconductor technology, the AR, VR have become so predominant that you can see by wearing your wearable technology, virtually you can see what exactly is happening inside your PCB layers, which is having issue, where exactly the component is sitting, where exactly the component is not sitting, which pin is having damaged, which pin is having an issue. All these things you can simulate, you can process it, and you can analyze it. So obviously, AI has become very vital. You can do the predicting models, you can do the defect detections, and you can also, these particular algorithms can tell you which material that will be utilized have the highest failure rates. which material is used for what kind of purpose, what kind of cards, for what kind of techniques, what kind of usage, have the failure rates, the success rates, everything it can predict and tell us. That's how the AI has become more and more actually prominent now. Okay, so with this, my actual presentation is done. Now, the next half an hour, I'm going to touch upon the career guidance which I wanted to really give to all you people, at least those who wants to benefit. Correct? There is something called. How many of you know, by the way, circular economy, linear economy? I'm not talking about finance here. Okay, I'm not talking about anything related to money. Don't get misguided with economy. Okay. So I think I found people are very shy in Anantapur. Okay, no problem. So linear economy is anything that you make it, use it, throw it. Okay, that is called linear. It is line. You make it, you use it, you throw it, which is like use and throw. That's called your linear economy. Circular economy is that recycle it, refurbish it, reuse it, and repurpose and retain. This is called circular. The circular economy mostly focus on sustainability. Correct? You take any industry today, whether it is a semiconductor industry, whether it is aerospace, whether it is a retail, whether it is a BFSI, whether it is a CPG, whether it is any railways, anywhere else, no? Your sustainability has become a very key component. It is very, very important for all of us as an individual that Mother Earth has given to us. All the laurels that we are enjoying today, we need to safeguard our environment. So sustainability has become a major, important topic nowadays. And there are Paris Agreement to ensure that the overall, the entire world temperature need to be reduced by 2 degrees centigrade by 2030. They're all like Paris Treaty. These are all called, correct? There is untapped business of $4.7 trillion. I'm not talking about billion dollars. I'm talking about trillion dollars. $4.7 trillion of untapped business exists in this circular economy, only in sustainability. Whatever you think from sustainability point of view, you will have a money over there. You save the environment, you get the money. That's how the business is running now. Okay. So I'll just give a small example. You know, how many of you know, like, I mean, those days where we used a lot of plastic plates, plastic spoons and all. Nowadays it has reduced. We are all using something like arachnid plates, and then you are using like your banana plates, no, kind of, no, like hard pressed spoons and all. That is a big industry. There are very young entrepreneurs, like college pass out people. They started their own business to ensure that the sustainability is being used in food industry. Correct? This is one of the business. And in Rajasthan, there is one young engineer who graduated, used all the plastics, the Bisleri bottles, and the plastics that we used. He started constructing the house using the plastics. See the innovative ideas, the waste management, correct? And if I tell this figure, you will be shocked to know there is $127 billion of waste management generating the business. See the entire world, how it is looking, where it is going. Every nook and corner, there is a business opportunity. You just need to think out of the box, ensure you will utilize that opportunity, and then you can make money. Okay, let me come to now AI. That is one industry. Sustainability is a one industry. You can all think about it, and I know that it is not cup of tea for everyone, but that is an industry. I also urge everyone, if you think something differently, do it. Okay, lot of money is there. I told you the figures also, how much money you can make. Then the next trend that we are seeing is a Gen AI, generative AI. You know the difference between AI and Gen AI? No? Can anyone tell me what is the difference between AI and Gen AI? In the name itself, it is there, na? Gen AI is nothing but generative AI. What it generates? You can generate anything. Give text, generate image. Give sound, generate text. Give picture, generate sound. This is what I'm just giving an example, generative AI. Okay. Now, what is a normal AI? Artificial intelligence, there are two models out there. One is a foundation model. Then the second one is called LLM, large language model. So this foundation model, it is a supervised learning algorithm. The deep learning algorithm will be there, where it will use the neural linguistic programming and your machine learning techniques. You will write the algorithm, you will label the data, you will feed it to them, and then it will process it. It will tell you. That means, like for example, you show 10 different kinds of dogs pictures, and then it will learn by looking at all these things. You will label it very supervised learning. This is called. You will give the labeling. This is called. This is Alsatian dog. This is that. This is cat. This is what and all. And then ask what is a dog. It will tell you the dog is like this. But in the case of LLMs, it's an unsupervised learning. Correct? You will start giving them a different dogs, cats, rats, and all everything. You are not giving any supervised directions in LLMs. You are giving multiple pictures to that, and you are asking it to generate dog. Now you tell that I have given you millions of instructions. Now you tell me what is dog. Then it will go search inside and do the algorithm, and then do the everything processing through the algorithms. It will give you, okay, I have got so many things. The dog looks like this, and it will give the dog picture. I'm just giving an example between the LLM and functional module, and as well as large language module. The large language module is a subset of your functional model. Okay. Now, when these two get integrated, your ChatGPT. How many of you use the ChatGPT? Do anyone know what is ChatGPT? I think you must be knowing it. You guys use ChatGPT?
Yes, sir.
Yeah, correct. You use it for your research. You use it for your notes. You use it for everything. Correct. This ChatGPT is nothing but your LLM. You ask anything, it will give. It will go search and give you. This is that is an example of your large language module. Okay. And AI functional module is a predictive. It gives the predictive analytics. It gives your predictive, what you say, like it gives a lot of predictions, like how exactly the model exists, what exactly in future it looks like, all these things. These are very, very widely used across all industries. You will be shocked to know in future, imagine, correct? Imagine if you have a ChatGPT licensed version, you take it, OpenAI, Gemini, or whatever it is there, correct? You take it. Do you really require a lawyer? It's become very threatful profession using this AI in foreign countries. Normally, what advocates does, the advocates basically required a case references, constitution laws, any references, correct? If any case happens. So this is the reference of the case happened in Punjab court by someone so and so. This is the law, IPC section so and so. All these things they will tell. Imagine using these GPTs, correct? Just tell that this is the problem. I require notes to read in front of judge. It will prepare you a big chart with all the sections, with all the reference cases, everything. Okay? You don't require lawyers. I'm just kidding, actually. I mean, that is the situation right now. But it is also important we train those models, we digitize them, we feed them, correct? We train them, correct? We will tell them, okay, so today you do something, immediately we'll feed it. So this will, see, we people, humans, we will read, we will analyze, we will write, we will forget. But it is a mission. It doesn't do like that. It will read, it will absorb, it will memorize it, it will retain it, it will reproduce it, and it will speak. The only thing it does not do is feel, like how it does, correct? Even if you feed that, it might feel, we don't know. Imagine this, you see the where world is going on, where it is heading, and you have untapped, and trust me guys, this generation, correct, people who are passing out this generation, you are the most beautiful era of human existence. So much happening, and people, me, and of course most of our professors, we are all millennials, maybe the fag end of 70s, 78, 79, maybe the start of 80s and all. We are fortunate enough to see 4 industrial revolutions. 4 industrial revolutions. We have seen industries where there are no mobile phones. We have seen telephones, wide phones. We have seen pagers. We have seen mobile phones. We have seen satellite communications. And the youngsters now, you people have not seen those things, but we have seen. We know the advantages, we know the disadvantages, we know where to use, how to use, what to use. 25 years back, when we passed out, there is no internet. I still remember I came to Bangalore for doing my project work. There was a discount between 5 a.m. to 8 a.m. 1 hour internet, 20 rupees. Just to do that internet, we used to go from almost travel 20 kilometers in the bus, stand in the morning, the internet center will open in MG Road. Myself and my friend, we both go take the floppy and put the resume and apply for jobs. Because I'm talking about there's a situation that time. So you might laugh like 50 rupees per hour. Now 50 rupees is nothing. But those days, 25 years back, 50 rupees is a lot. You can do many things. So 20 rupees per hour, just to save 30 rupees, we used to do like that. But today it is not like that. I'm sitting here in Bangalore and talking to you people in Anantapur. You people are aramse sitting at home. Somebody might be listening, somebody might be watching by looking at this session. They would have gone to Instagram, Facebook and all. You might be doing that. See the luxury that technology has provided to us now. Understand? So, one, I told about sustainability. That is one area. Second, I'm talking about artificial intelligence, machine learning. And now I'll talk about digital twins, which is nothing but your augmented reality and virtual reality. It is not just gaming. I'm telling you, there are companies that heavily invest on research of this AR, VR. These tools and techniques, no, where human cannot go, they will send the drones. They will see places where humans cannot even enter. They will send the drones. They will take the photographs and they will process it. And this will be digitized and stored. Next time when there is a problem, This AR/VR technique will automatically tell you that for so and so problem, this is a fix, and please go ahead and this is change it. That's how the industry exists now today. So AR/DR is AR/VR, which is a digital twins. This is another stream of line that you can think of it. It is existing now. And of course, my dear friends, I'm telling you, AI is no more a software. AI is everywhere. It is Sarvantaryami. Everywhere it is there, like Sri Krishna. Okay, it exists everywhere. It exists in law, it exists in retail, it exists in technology, it exists in semiconductor, it exists in defense, it exists in everywhere. You have to understand, you need to understand the AI techniques, you need to understand the basic bare minimum terminologies, the basic bare minimum understanding on what exactly is the deep learning algorithms, how exactly it is being written, what is the techniques and all, everything you need to understand. Okay. I just gave an example of law firms, how exactly they are using. Medical, I can give lot many examples. And I will give one more example in BFSI. You will be shocked to know this is a use case. Correct? You have a bank balance, and of course, everybody have. You know, you will have a bank balance. You will draw money. You will do all the transactions and all. You will go Mintra. Now it is a Black Friday, Thanksgiving Day. You will do some shopping. Everything you does. You know that what happens. Every bank has put AI. It will does your spend analysis. What is your capacity, spending capacity? What is your appetite? Let's say you are earning 3 lakhs per month. You are spending 2 lakhs. It does the analysis of all those data. And automatically it will tell you, my dear friend, you are spending 2 lakhs per month. This is your spend analysis. Looking at your history, where you are spending, what you are spending, your investment portfolio is this much. You invest this thing, after 10 years, you get this much money. You invest in stocks, you invest in mutual funds, you invest in commodities. It doesn't tell you and recommend you. Apart from that, unfortunately, you would have gone for your diabetes testing every month. Imagine the situation where you will pay, or it will look at your medical payments, correct? You do all the Google Pay and all, correct? It will does the analysis also, saying, my dear friend, you are a patient. So take this medical insurance because you need it. Some 10 times you have gone for hospital in the last 10 months. This is your diabetic routine. These are the offers that exist in market for your diabetic testing, blood testing, H1B1C. Take this. You imagine the situation, it has gone that level, my dear friends. So that is the level of aid. So everywhere it is there. Everywhere it is there. Medical it is there. Retail it is there. Now come to the retail. You open your Google Chrome and you go to Mintra, Ajio, or whatever it is there, you do the shopping. Correct? You will look at some 10, like 10 shirts or 10 pants or 10 saris or 10 frocks. You don't buy anything and come out. Have you ever observed? Next time when you open the Google Chrome, it will keep populate and keep telling you, saying that the one what you have watched, this particular shirt, the percentage has come down now. It is now, there is a discount. It keep flashing it. Have you observed this one? Have you wondered who does all these things? Shall I tell you one small thing? That is called teasers. The percentage that is showing, it is only for you. It is not for your friend. When you log in with your email ID, with your mobile phone number, and you do the browsing, and you not to buy it and just add to the cart, or maybe just look at and discard it, it carries the data. This is called structured data, unstructured data. It will does all the data analysis, and it will tell you, these are called teasers. It will tease you and it will enforce you to buy that particular thing, saying that it is only discounted. The moment earlier would have some 700 rupees shirt, you just add it and leave it. By after 5 days, if you open a browser, it will tell you 700 became discounted. Now it is 350. Will you not buy or not? You will buy. Once you go there, you add it to the cart, you will buy it. Immediately you see some other thing that would have costed you 1,000 rupees, and then you leave it. Next time it will become another 200 rupees or 300 rupees. You will buy that also. This is called dynamic pricing algorithm. It is at an individual capacity. Okay. So that's why I'm telling you AI is everywhere. The other, I spoke about sustainability. I spoke about AI enough. I spoke about digital twins. Now I'm going to talk about another very important technology, the trend that exists in the market where you can make your careers. That one is called cloud. Cloud, correct? Everywhere it is there. Now, you might all think the data centers, the applications, everything it is become SaaS based and it is moving getting cloud, correct? Everywhere it is cloud. But cloud is not real cloud. It is not going and sitting somewhere in the sky. It has to be on the earth. Where it is going, it is again going into a data center. It is again going into your physical compute. It is again going your physical nodes. It is again going your physical DC. So the only thing that we call it as cloud is that you are no more going to maintain the data center. There is somebody else who does it, who will just use it. That's the reason we call it as cloud. Now, what I wanted to talk about is also the data center technologies. This is also infrastructure, and data center is also a booming field. It was there, and then we are moving or migrating on-prem to cloud. And when I say to the cloud, again, you have a lot of hyperscalers exist in the market, AWS, Azure, Google Cloud. Okay, try to make your career in that, and it is all vast ocean, and there are 180 cloud native services available in AWS, or more than that, I don't know. I think it is more than that only. Similarly in Azure. So pick up anything. There are so many things, like, I mean, you can say, like, I'm for testing, CI/CD, continuous integration, continuous delivery, DevOps, DevSecOps, security, cyber security. And I wanted to re-emphasize on that. With all this AI, with all this cloud, with all this data center moving everywhere, data is abundantly available in the market. The data sciences, people who invest time in learning, data scientists, becoming data scientists, data sciences, the next coming 15 years is for them. I heard one of the article in LinkedIn. You required almost 30,000 data scientists for the industries, but the existing data scientists are hardly some 5,000, 6,000. The demand is so much. And the another area I'm telling you, statistics is going to be a next evolving boom. Trust me, you remember this, mark my words. Because all your structured data, unstructured data, everything is revolving. For that you require statistical models. For that you require people who know statistics. They just need to make 1 or 2 languages to learn. But that is another area you think of. Okay. And we are talking about semiconductor technology. Here also AI is there. Utilize it. You may come and ask, like, Mr. Hari Krishna, you are talking about AI and all. Today topic is semiconductor. We are all doing research in semiconductor. What will happen to us? I'm not saying there is nothing going to happen. This is an evergreen field. The only thing that you need to develop is that develop your secondary skill. Okay? Develop your secondary skill. Let this be your primary skill. Enhance your secondary skill. Utilize it, use it, and make it for your purpose. Okay. And I just wanted to give you another, just maybe a side note. Have you ever wondered how much of carbon dioxide, or maybe how much of power it takes to store 1 GB of data in a cloud, on your cloud? I read an article. I was so shocked. Just to store 1 GB of data, you required 0.28 kgs of carbon dioxide emission, and it takes 0.015 kilowatts of power. Now we keep taking photos, we keep taking videos, we keep uploading it in the cloud, Google Cloud. Correct? We have Google Drives, Google Cloud and all. And this is another information I'm giving to you. You will be shocked to know the global computing range of the carbon footprint, the emission of the data centers that are giving from 2.5% to 3.75% as per the global greenhouse emissions standards. This is much bigger compared to the carbon emission that a commercial aircraft is getting generated, which is of 2.4%. But the data center and the cloud that we are using, the emission rate of carbon footprint is 2.5% to 3.7%. It is much, much bigger. That means you can fly a commercial flight with an emission of 2.4% carbon emission compared to the storage of your data in a data center, which is more than 2.5 to 3.7%. You can imagine how much of what you say, environmental hazard it is going on. That is the reason I'm telling you circular economy. That is the reason I'm telling you require sustainability. Okay. So I have told what I have experienced, and I have given what I have seen. And you people are more smarter than me. You people are more intelligent than me, and you know more than me, because you are research scholars. You are invested time in the academia, and you are learning. So use your wisdom for your purpose. Utilize it. Okay, and please start developing your secondary skills while your primary skills be your core competency. So I will leave it over there. Okay, I still have 2 minutes. I think I have a practice of dot where I will stop my presentations normally in office also. When I'm presenting to my customers, I will exactly stick to the point. Okay. I can take a couple of more questions. I have 2 minutes time. Are everybody sleeping? 9 o'clock already.
No, sir. We are interestingly listening to your concern.
Sir, good evening, sir. Good
Yes,
evening,
yes.
sir.
You come on video, ma. I can able to see then. At least you.
Sir,
If you are comfortable, then only. Yeah, please ask the question. Yeah.
sir, as academicians, nowadays research is going on nanotransistors like CNT FET and carbon nanoribbon GNR FET also. So in Cadence, how to use those tools, sir? CNT FET like GNR FET, sir? Is there any possibility, the academic people?
See, actually, I'll tell you this, especially the Intusoft, Cadence, Synopsys, Xilinx and all, no.
Yes, sir.
You need to contact, I don't know, you have any partner ecosystem in your universities or not. Normally what happens now, in every company, there used to be a business development manager for these products, no. They used to have a partner ecosystem. They give the demo licenses for them, okay, to to a very smaller extent you can use it, but not at the full throttle. For example, I will tell you, when I was doing my programming in microcontroller, there is a compiler called IAR. So what it does, like it used to give me the demo license of some 2 MB or something like that, where I used to write the code, I can simulate it, I can see it. But beyond that, it is a licensed. But at the same time, the cost of the licenses for the education sector is much lesser compared to commercial usage. So in case if you have any, I don't know how the model exists in universities. If you have any partner ecosystem focal, no, you can able to contact those industries and get the code for your demo licenses, or they may even give some free licenses also.
Okay, sir.
Okay.
Actually, they are providing the bundles for CMOS, sir. We have that CMOS technology bundles, sir. But we don't have CNT FET or GNR FET transistor technologies. Is there any possibility? That also we don't know, sir. If there is a possibility, then we can go for it.
Yeah, I think you need to find out. I may not be aware of this one. I'm sorry. I don't have the right answer for this, but that's how normally it happens, what I know.
Okay, sir. Okay, sir. Thank you very much, sir.
Thank you. Any other questions? Anybody? Okay. If nobody have any questions, and thank you very much. Over to you, sir.
Thank you, Mr. Harikrishna, sir, for delivering such a enriching and comprehensive session which covered 3 different areas. The way you have shared your real-time experiences and also provided some career guidance related things, especially on sustainable industry, Gen AI, digital twins, and you also spoke about the marvels of AI, how the AI can really change and make the difference, and how you are encouraging us to have the secondary skill is really awesome, sir. We have thoroughly enjoyed your session and really enriching for us.
Yeah, thank you very much, sir. I would like to have in presence. Maybe I think next time we will see an opportunity. We'll see an opportunity where I come in person and then see all the people. That will give more interactive sessions rather than just being offline.
Surely, sir. You are welcome, sir. You are welcome.
Okay. Thank you very much, and thanks to Anjulata and thanks to Chandrababu Naidu sir considering us as a privileged member of this particular week. Where you feel that we can able to contribute something, and thank you very much for that.
Thank you.
Okay. Yeah, thank you. Bye.